And
hello, for those of us joining us, we are going to give just one more minute as people are funneling in, and then we will get started. I'm going to send you a link for all of the webinar links today in the chat, so be on the lookout.
great. Looks like people are jumping in. This is exciting. Yeah, welcome, everybody. We'll get started just in a minute or so. Maybe a little less.
All right, if you're just joining us, I just put in the link for the Google Doc that has all of the webinar links for today. So make sure you get in there and check out all of those links, so then you don't have to ask us for them later.
Yeah. Great.
All right, Rusty, whenever you're ready.
Okay, well, great. Well, let's go ahead and get started. We're going to dive in. So Kristina and I are very excited to be hosting this webinar on one of my favorite topics, AI. So before we get started, Kristina put up on the screen just ways that you can get in touch with us. If you want to connect with us, you can always connect personally with myself or Kristina. But if you want a more generalized approach, please send your questions to info@ubtecheducation.com, and tag us on all your social media needs, LinkedIn, Instagram, Facebook, anywhere at UBTECH.edu. And of course, you can always visit us on our website at ubtecheducation.com. And kind of as a warning, this webinar is being recorded and it will be hosted on our website if you guys want to check it out after this live webinar.
And I want to throw in there that you guys, there's going to be a lot of information today. We've got a lot of slides. We might go over on time, just FYI. So if you need to jump off, or if we're going too fast for you to take notes, we want you to know it's recorded. You can always come back and look at it. So don't stress out. You can always come back.
Great. Excellent. And you guys probably are pretty comfortable or probably know who we are, but just in case you don't, my name is Rusty Nye. I'm from Long Beach, California, and I am the EDU product manager. So I do recommend you guys connect with me on LinkedIn. That is my LinkedIn profile picture. So if you find that guy on LinkedIn, that's me, and send me a note.
Yep, and I'm Kristina Davis, educational specialist here at UBTECH Education. My email is there. You can get with me on Twitter or LinkedIn as well. Follow me, I'll follow you. We love to share stuff that we see in the classroom, so find us.
Great. Excellent. And for today, we're going to tackle just a few different bullet points. We're first going to introduce you guys back to who we are as a company. Then we're going to kind of go into our topic, which is getting comfortable talking about AI, getting comfortable teaching AI. Before that, we're going to kind of establish what we mean by AI and why this is something we'd want to talk about. And of course, we'll wrap it up trying to answer as many questions as we can. So I think this is a fun session. So let's go ahead and dive right in.
I left one bullet point off. We'll tell you about next month's webinar as well.
Yeah, of course. Great. So if you're unfamiliar with who we are as a company, we are a global leader in engineering and creating robotics for different applications. So if you'll see, we'd like to examine and look at a few of our favorite robots that we've created. In the center, you'll see our newest endeavor, which is a Addibot S, which is a disinfection robot utilizing UVC. We also have one of our newest humanoid robots, Walker, which you'll see on the right side of the screen, which is waving at you guys. So If you see any of these on your social media platform, if you see Walker or Addybot, definitely, like it and tag it and share it for all of us to see. Great. So in terms of who we are as a company, in terms of UBTECH Education, we are a specific division of UBTECH Robotics, where we develop educational solutions specifically designed for the classroom. With that being said, we also tailor all of our hardware and software and accompany that with curriculum as well. Excellent. So first, when we dive into this topic, I want to ask you guys, maybe can you guys answer this question in the chat box? Try to define AI, so artificial intelligence, in a really easy to understand approach. So how would you be able to answer this question if, say, an elementary school kid asked you, what is AI? So does anyone want to try? I'll give you guys about 10 seconds or so. If no one wants to take a stab at it, that's why you guys are here, right? Oh, great. So someone said a self-deciding robot. Yeah, definitely. Intelligence demonstrated by a machine. It is a machine learning from the environment. All really good approaches. I like this. So the way that we can define AI is artificial intelligence being this umbrella term where computers, software, robots, other computer-controlled devices imitate intelligent human behavior. So that's kind of a key way to define and talk about AI, is that AI is something that's able to think, process in similar ways to human beings. So what do we mean by that? Really, making decisions, deciding something, and being able to kind of think in similar ways that a human would. So why would we be so focused on AI now? So this concept is not new at all. So the concept of artificial intelligence has actually been around for quite some time. However, new advances in technology, specifically hardware, are what making it possible for AI to be everywhere. And we interact with AI, most of us, on a daily basis. So hardware, specifically GPUs, the ability to store and access big data, the ability to share models, hardware integration such as sensor integration and IoT are all making it very possible for AI to impact us on a daily basis. So we pulled out a couple of quotes for why this is so important now. Excuse me, but these are kind of something that's important to us when we're deciding why we should be focusing on AI education. But I'll just read, maybe the first one. But as we'll see, 89% of US-based companies are planning to adapt user and entity big data analytics by 2022. So this is huge. That's coming up, and 89% of US-based companies are planning to utilize elements of AI in their everyday businesses. So this is why it's so important for us now to start training and teaching concepts of AI to our students, because this is something that's going to continually impact jobs, careers, businesses, etc. Great. Kristina, you want to advance? And also, this is a slide that Kristina touched on in the last webinar, but considering where we currently are, a lot of people are really focusing on the fact that we're on the dawn of new industrial revolution, where we're going to be utilizing AI even more, in the coming years. So again, the better we can start approaching and integrating some of these concepts into our curriculum, into the school, into all elements of education, the better we can prepare those students for these changing careers into the future.
And just to note, if you're in the webinar links resource that I put in the chat, if you go all the way down to the bottom of the second page, I left in the 3 that I had in from last month's webinar. So there are some 3 about the 4th Industrial Revolution, 3 articles that you can take a look at.
Great. Thanks, Kristina.
All right, so 5 big ideas of AI education. So we're going to go through the next several slides. We're going to break down each one of these big ideas. We're going to tell you the driving question, the description, and the learning goals for one example, like one of our AI Foundations lessons. And then we're going to give you a hands-on activity that you can take away today and go use with your students that doesn't require any additional like robot kits or things you have to purchase. It's all free resources or things you have around the classroom. And then we're going to give you some example like of a resource that you can go to right away, whether it's a video or a website or whatnot. So if you're following along on the webinar links page, you can see it's broken up by lesson. So you can follow along on those. So our 5 big ideas were modeled after the 5 big ideas from AI for K-12, which is an organization that's putting together standards that could be adopted nationwide for artificial intelligence and for teaching in the classroom. So this is our graphic, our version of the 5 big ideas. And to the left, we have some examples of topics that we talk about in the lessons in our curriculum with the students for each one. So for example, like perception, number 1, where computers perceive the world using sensors, the students might talk about sensors, signals, algorithms, inputs, outputs, all sorts of things that go in with perception. So we're really trying to break up each of those big ideas into what is the basic knowledge students need to know. So for K-12, for K-12, for K-2, it might be they need to learn about the senses, right, before they can understand computer sensors. And then as you get into high school, then they go into more in-depth topics that deal with perception. Like autonomous vehicles and what your phone can do with all the sensors, right? So we really try to level it and to just start with the base knowledge. So here's our first one. Go ahead, Rusty.
Great. And so how we're going to kind of structure this talk, just as Kristina mentioned, is we're going to introduce, one of these specific lessons, and then Kristina's going to follow up with ways that you can really get started teaching one of these big concepts. But we did kind of pull out a lesson from each of our different units. So all of our curriculum is structured in different grade bands. This example being from our AI Foundations unit for grades 3-5, unit 1. So here, this big idea that we're trying to tackle here is perception. So this is kind of your foundational approach to understanding and utilizing AI and concepts of AI. In order to kind of introduce the concept and get in there, first you want to understand and tackle this idea of perception. So what do we mean by perception? So this is really the idea that we're trying to analyze how computers are able to perceive the world utilizing sensors. So in this first lesson, we would ask the driving question, how do computers perceive the world? What are limitations, or what limitations do computers have with perception? Here, the main topic here, the students are going to explore how humans perceive the world utilizing senses. And then they'll utilize or learn how computers are able to do something similar utilizing sensors. Some of the big goals that we would set for the students here is to be able to define perception as well as define what a sensor is. We want the students to be able to identify various robotic sensors and also compare and contrast those with human senses. And lastly, one of the big goals here is we would want students to be able to explain basic computer perception limitations. So this very introductory approach, again, we're focusing on grades 3-5, for this example. So this is kind of the way we would set it up, and then we would, move into an activity they would do. Great.
All right, so before I get started on this activity, I think we both failed to mention that if you have questions as we're going through this, please feel free to type them in the chat. We'll collect them for Q&A at the end, or if we can address them as we go, we will do that as well. So make sure you're putting stuff in the chat if you have a thought that comes to mind. Okay, so our lesson plans, all of our lessons are split up into the 5 E's. So if you follow that, you will understand that. If not, it is We try to engage the students before they explore a concept. After they've explored, we have them explain what they know so far. Then they go into elaboration. So they elaborate on the knowledge that they have, and then we evaluate. So this is part of the elaborate activity from lesson 1 of the grades 3-5 unit 1 guide. So students watch the video Haptography, Digitizing Our Sense of Touch, which is linked in the Google Doc that I shared. So you can get to that video. So you would watch this with students, and then you would have them discuss, and you could use these questions or ones you come up with your own, but what sensor are they talking about in the video? Which of the 5 senses does this sensor try to replicate? And where would you like to see this technology utilized? Like, where would kids think this would be really cool or really helpful to see in the world? So just having a discussion and getting them engaged in what is our sense of touch and how can robotics tie in with that. Then once they've discussed it, then you could have them do one of the 2 activities that follow. So either you could ask them to develop a new computer sensor using the engineering design process. So we have our own at UBTECH, but if you have one that you use at your school, that's fine. You can Google engineering design process and come up with thousands of different ones. But have them follow a process where they have to come up with their question, and then they have to research and they have to prototype and test. Okay, so students, this could be just a drawing if they have to, just draw if that's what you have available, or if you have building materials, cardboard, straws, paper plates, all that kind of stuff. You could have them build a prototype of their own sensor, and then there are some questions there on the screen that could help you get started if they need work or help going through the process, depending on how much experience they have with the engineering design process. And then the other option for an activity would be to have students research advancements in computer sensors. So your older kids, if they're used to doing the research, or if you're at a school that does that, then you could have them research first before then they create their own. But ideally, point number 4 there is you want them to create a final product that can be presented to others. So this could be a sketch, like I said, the 3D prototype with building materials. It could be their research findings. They could put together a presentation, a sales pitch, so on and so forth. You want them to create their own sensor. What sense does it replicate, and how could it be used in the world? So your resource that's on the Google Doc is going to be this video that I mentioned that you would have students watch. Haptography and Digitizing Our Sense of Touch. This is a TED Talk, which is great because then if you go to the link, then you can also, they have questions and other activities that you can do with TED Talks. And then a little bit about Catherine she's from the University of Pennsylvania Engineering Division. So you can look her up. There's lots of information out about her as well. So that was just a little taste, a little bit of one of our lessons for perception. We will move on to lesson 2.
Great. So in this example, lesson 2, we're tackling the second big idea, which is representation and reasoning. So this is rooted in understanding the idea that agents or AI models or AI agents maintain models of representation of the world and use them in order to reason. So this is kind of getting more, a little bit more in depth in terms of what AI is and how it actually utilizes it, or how it actually works. So we asked the students, and I guess I should back up and say this is example, we jumped a few grades, and this is actually from our 9-12 unit 1. So it's something you would utilize with high school kiddos specifically. So we'd ask that driving question: what do models and algorithms represent in artificial intelligence? How do these representations help computers solve problems and make decisions? So those are some big questions here. And this is through this lesson, they'll really be able to intelligently and thoughtfully answer, those specific questions. So throughout this lesson, the students are going to be asked to consider how a new student would navigate their school and then their town. Students will work through these problems, learning about a specific model, algorithms, and how representation will help, guide the students, through their school or town, but also how that applies to these concepts of AI. So notice we're teaching this, big idea of AI, but we're not actually utilizing a computer for this, we're approaching it from a different way. And some of the goals that we would hope students would come away with here is that students would first create an algorithm for others to follow, and they'd also analyze its accuracy. So they'd really be looking at the algorithm they created, and then also, seeing how they can improve upon that. We'd also want the students to gather and synthesize information on knowledge representation. From there, we also hope that students be able to analyze data to determine an optimal solution to the presented problem above. Great.
Okay, so in this one, this is the engage activity, part of the engage activity. So this very start of this lesson, introducing these concepts to the students, and it's really trying to tie it back to them and making them think about themselves, right? Because then it will help them understand the new concepts more. So the following scenario, you can present this scenario, or if you have any other scenarios in mind that could work, you can change it up. But the one we propose is, imagine you're a new student in the school. To avoid having to ask other students where you need to go, you have requested a map of the school, a seating chart for each classroom, and a class schedule. Explain to a partner how these models could help you on your first day at this school, so this new school, right? And then once you get them discussing and talking about, are these helpful, are they not? How helpful are they? You want them to then consider the accuracy of the information. If it's printed material, how up to date is this printed material, right? Are the seating charts up to date? Maybe the classrooms have changed, right? So it's something to consider of, is this really the most relevant information that's going to help this new student? Okay, so then as a teacher, you would then explain, well, while these models are great, right? The best way to learn how to navigate any new place is to either get directions from somebody who's there, who's familiar with it, or trial and error, right? Just going around and figuring it out on your own when you have time. So from here, you're challenging students then to take their setup in their school and to provide step-by-step instructions for this new student to get from the main office, wherever the main office is at the school, to the classroom they're in right now with as many details as they feel is necessary to complete the task. And you're gonna find that as students do this, some are just like, okay, from the office, you take a right and then you take a left and you go straight and it's the room on your left, right? So they're leaving out a ton, right? And then you're gonna have some that are very specific, but maybe specific to their experience, right? So they're like, well, you go to Mr. Nye's room and then you take a right at Mr. Nye's room and you go to this room for this other teacher. And that new student's not gonna know those teachers. They're not gonna know the names unless they're outside. So this all brings up a great discussion of how accurate were your directions? How helpful was it? Did the person looking at it understand or not understand what you meant, right? So all these questions can be asked after you have the students swap and try to follow the directions if they can, or just read through them if you can't leave the classroom. But just really trying to get them to think, did I give that person all the information they need to go from point A to point B? Because as we know with computers, you have to give them everything they need to know. They can't infer, they don't really ask questions, right? We've got to give them everything they need. So the resource you have on that Google Doc is Google Maps. Now, while it was not used for that activity, it is used for another activity in that lesson. So Google Maps is a great place to start looking at maps and how maps model the world around us, how they're a visual representation of what we know.
And I love this example of Google Maps utilizing to reinforce that second big idea. Because you'll see the way that map actually works is you're moving it, you're moving the cursor, you're moving the virtual person through this, world that's all defined and created by patterns, by models, that representations of that specific data of that place. So it's a great connection, in my opinion, and something that can work on all different levels, all different grades. Excellent. Well, great segue to the third lesson, tackling the third big idea of AI education, which is learning. So this example we pulled from our K2 grade band unit 1. So this is for those, those tiny little kiddos. The big idea that we're focusing on here is how computers can learn from data. So you'll see to kind of lead, through this progressional approach, understanding AI. First, we tackled how computers are able to perceive their environment, so take data in as well. Then we focused on the second big idea, representation and reasoning, how computers are able to create models of representation around the world. And now we're focusing on how computers are able to learn from all of that data that they've been able to collect. So for this specific lesson, we would ask the K2 kiddos, how can we use patterns to make predictions? So taking a kind of bird's eye view approach of this concept, and students would be able to, or they will be using a tree as inspiration. Students work together to figure out the standard features and patterns a computer would use to determine if something is a tree. The goals that we set for the students here are we want students to be able to define pattern and prediction. We want them to design an image based on agreed upon commonalities. We'd also like them to compare designs and locate specific patterns. We want them to observe a computer making predictions. And then we also want them to be able to summarize how patterns can be utilized to help make predictions. So through this particular lesson, these young kiddos will still be able to very thoughtfully, be able to tackle this idea of computer learning, of machine learning. Great.
All right, so for this activity, students are going to get to draw in color, which they love at that age, right? So you're going to start by having a class discussion on trees and focusing on what trees have in common. So the major topics of the tree has a trunk and it has leaves, usually, or flowers and branches and bark and animals that live in it and all sorts of things. So you want to make a list of that stuff so the students can reference it later, but just have a big discussion on what do you know about trees? What can we say is common among those trees? Then from there, you're going to give the kids each their own piece of paper and then crayons or color pencils or markers or whatnot, and ask them to draw a tree using as much detail as possible. So really give them time to really expand on this drawing. We don't want just the normal, right? Like a little cloud and then a trunk. So giving them time to add and make it as creative as possible. Then once they finish, you're going to display them all up so everyone can see all of the trees. And you're going to start asking kids to point out the differences. So I posted 3 trees here when I just typed in, Google trees. There are 3 different trees. We can already see the trunk widths are different. The color of leaves are different. The number of branches are different, right? So still using those common things, those common pieces we talked about, but that doesn't mean that they're still all going to be identical. So it's something for the class to analyze, and they're going to discuss and they're going to look at. Then you're going to give the students back their drawings. And as a class, we want them to label all the parts on their drawing, right? So you're going to label the common parts of the trunk and the bark, if there's bark, and leaves and branches, so that they can see, even though my tree looks different from this tree, we have the same pieces, the same commonalities, right? And then that's where you go from discussing patterns, making predictions. So as you can, we're going to give you a resource here in a second, but if you're thinking of just things that students might be familiar with, you could do Pictionary or any other kind of drawing guessing game, right? Where you could say, hey, if I were up here and I were drawing lines going down and I drew some lines going out, could you start guessing what the item is, right? And that's really how computers learn as well. They take all the samples of trees that they can find and they find all the commonalities. So then they can make predictions on, oh, I think this is a tree based on what I know about trees. So you're giving students the background of that without jumping into the computer portion of it, the machine learning portion. You're just teaching them predictions, patterns. Okay, so they would categorize then the term tree. And the resource for this one, I didn't realize I had them all separate here. Okay, the resource for this one is AutoDraw, and this is used in the elaborate section of that lesson. So once students do, I'm pretty sure at the beginning, the engage activity is like a Pictionary game. Then they go into this tree activity, and now they get to see how a computer uses what they just learned, right? So here's a drawing of a tree. And so with AutoDraw, as you are drawing, the computer's trying to guess what you are, right? Isn't that right on this one, Rusty, or am I thinking the other one?
Exactly, yeah. So yeah, like this example here, you'll start drawing a tree, and then it will, based on how you drew it and which line you put where, you'll see it will start making predictions on what you're drawing, and then it'll fill in the gaps, of that tree or something.
That's right. That's right. Yep. Perfect. So that's the resource that's in that Google Doc. If you guys are interested in using it, super fun. Kids love it. Yeah. So there we go. So it kind of helps them understand how the computer then can do the same thing. Moving on to lesson 4, natural interaction.
Great. And so now to tackle this 4th big idea, this kind of takes a step back, in my opinion. The first 3 ideas are really focused on understanding how AI works. Here with big idea 4, where we really start thinking about how we interact with AI. So it's more of an idea that the humans' interaction within AI is what we want to analyze here. This big idea really is focused on how developers strive to create different AI agents or models that interact with humans on a more natural basis. So this is kind of where you can make a ton of connections to back how we actually are interacting with AI on these daily basis. And here in this activity, we pull directly from 6-8. So looking at those, middle school kiddos, we'd ask the question, what limitations do chatbots have? So we probably all utilize chatbots, but these are different computer programs that are able to actually interact with people on a somewhat realistic basis. I know I get a lot of robocalls that are, some are better than others, definitely. But in this activity, students would explore NLP or natural language processing by creating their own chatbot in uCode. So uCode is our online browser-based coding environment. Through this activity, we set the goals for the students to be able to explain language processing is. We would also set the goal that they would create their own chatbot, so something very simple, simplistic, but a starting point for analyzing NLP. And we also set the goal that we want students to explain why AI would have difficulty with natural human interaction. So not just building the chatbot, not just following the steps, but also analyzing how we're interacting with it and how it is, what are some of the difficulties in trying to create AI agents that are very easy to interact with on a very personalized basis.
Yes. Okay, so this activity, you're going to actually use some resources from our website. So we've got on the Google Doc, we've got a link for uCode on there. So that is our coding platform. You've got a link to uCode resources and activities. That's from our website. There's other activities on there that utilize uCode. So if you want to use those at a later time. And then the 2 activities that we are using from that page are also linked. So you've got all sorts of options there. So for this one, super easy. This is actually the explain activity of the 5 E's for this lesson. And before this, they are discussing about chatbots. Have they interacted with chatbots? And then after this, they get to build their own more in-depth chatbot. So this is just using the sample chatbot instructions that are linked in the Google Doc. You're going to pull up our little tutorial that's UCO says hi. It brings up a program already. So the kids don't have to build anything here. You're just bringing it up so that you guys can use it as a discussion point. So you're asking students, what do you know about chatbots? Have you chatted with them before? What was it like? Okay, and then you're going to run the program and ask students if they feel like this chatbot is intelligent. And that's one of the vocab words in this lesson. You're going to spend time talking about it, but you want them to determine why is it not intelligent. Come to find out, this one is not, because you are just going to go in there. I got to even think what he does. He just says hi, and I think ask what your name is, and you type in your name, and you could type in banana, and he would respond with, hello, banana. Like there's no thought going into this. He's just repeating whatever is in the program. So there's really no intelligence here for that, in that portion, in that sense, human intelligence, right? Then from there, you could, depending on their coding background of your students, it's all block-based coding. So if they're familiar with that, you could have them try to create their own chatbot using the chat with UCO activity that's linked in the Google Doc. you could have them pull this one up and just kind of modify it and work with it to see if they can make it better. And then challenge each student or pair of students to add new blocks. They could add in sensors if you've got sensors or mics or cameras or anything that allows further interaction with the chatbot. But do know this is just going to be a basic chatbot for this lesson, and then have them test it out with others and have discussions on how they feel about it. Is it a natural interaction? Is it not? Just to go back a little bit, while they don't spend a lot of time talking about emotions and how we interact, right? It's not just voice, there's all sorts of things that go on, body language and inflection, and we cover some of that in the younger grades as well, so that by the time they get to 6, 8, we assume they have a little more knowledge of that. But you could always go back, and I should have said this at the beginning. You can go back and really use any of the activities from any of the grades, depending on your students. If it fills a need for your students, go ahead and throw it in there. But they can all be adapted as well. So like that 9-12 math activity, you could easily do with younger kids if your kids are familiar with your school, right? So know that this one can go up or down to depending on where your kids are. And yes, there's a question about adding the Google Doc. I will get that in the chat here in just a second. So here is the link for uCode. Again, linked in the Google Doc that I just put back in the chat. So it's idena.ubtrobot.com. Looks very much like a lot of block-based programming you've seen. There is uCode. uCode is our little lion, but that is our free resource. Oh, and that's the exact code, actually. Thanks, Rusty, for screenshotting that one. That code, right? That once the students click the green flag, uCode is going to say, "Hi, I am uCode" for 2 seconds, so it just pops up on the screen. And then he asks what your name is, so that's over on the right there. And the students underneath just type in their name, and he responds with whatever, banana, nice to meet you, right? So if they put in something wrong, he doesn't adjust his speech or what he's saying. So it's not going to be natural if they start messing with them, right? Mm-hmm. Right. Anything you want to add, Rusty, about uCode or?
I do think this is such a great place to start when introducing these concepts of, intelligent computers being able to, communicate with people. And I think if you'll see, just as Kristina, was mentioning, this does not use any, AI algorithms. However, what we can do here is actually within uCode, we do have integrated AI blocks. So you could actually build a machine learning model for uCode to reference to make more decisions. So basically what I mean by that, say if you wanted uCode to recognize between 3 different objects, you could build a machine learning model within uCode, within our platform, that's able to recognize and distinguish between these three objects, and then plug that into your code to have uCode be a little bit more natural in its interaction. And the reason I bring this up is, yes, this is a great introduction, but it doesn't have to just stay here. There's a lot of different ways that you can expand this type of sequencing to actually plug in something that resembles an intelligent algorithm. So yeah, this is just the beginning. And I think where it goes from here is, it can go many, many directions.
Hey, and speaking of that, next month's webinar is building off of this one. So we'll go deeper into some of those AI activities and things that you can do.
Absolutely. Yeah, great plug. So come back for more.
Great. All right, last big idea, societal impact.
So this is, and again, remember, this is kind of a progressional approach to introducing concepts of AI, these 5 big ideas. And what I really like about this framework is this last big idea, societal impact. So this really is intended to analyze the impact that AI has on our communities, our societies, in both negative and positive ways. So we want students to be, critical consumers of this type of technology. We don't want them to just buy in and say, this is the way it is, this is what we're going to utilize. But we want them to be able to reflect and, say that, there are good elements to it. There's also some negative aspects of AI, and how can we address those negative aspects? So in this particular example, we would ask the driving question, how does human bias affect the creation of AI? Which I think is such a important question for students to tackle when they're learning about artificial intelligence. So through this hands-on activity, students will explore and learn about these concepts of bias, equity, inclusion, diversity, and unintended consequences. So all very, very important aspects of AI. We would set some of the goals for the students throughout this lesson. First, we want them to discuss how their actions can affect others. We want them to also be able to define these kind of larger terms like bias, equity, and inclusion. And we also want them to elaborate on these terms of diversity and really figure out what that means. So again, some people may say that this may not fold in direct to a computer science curriculum. However, I think this is such an important aspect when analyzing these types of new technologies, that is something that's very important when you're teaching AI.
Yeah, I think it's always worth it to bring it back to the students and how does this affect them and how does it affect the world around them, right? It can't just be that we're users of technology and that's it, right? So this activity, it's the elaborate activity of this lesson, and it's really trying to get the kids to realize that even though you might get the same things as other people, it's still going to be different based on your experiences and your background and your outlook on life. And so for this activity, you start by telling students you're going to be as inclusive and equitable as possible. You're going to give everyone the same materials. They're all going to have the same directions, and they're all going to have the same amount of time to complete the activity, with the end goal being that all of their models look exactly like yours. So you're going to be doing this either as you're talking or ahead of time if that's not your thing. So you give everyone one piece of paper and you give the following directions with no elaboration. You don't answer questions. You don't explain more. You just give the direction and let them figure it out. So the first thing is you take a piece of paper, you fold it in half, and you tear off the top right corner, right? So you have everybody do that. And then you have them fold it again. That's all you tell them. Just fold your paper again, tear off the top left corner. And now you're going to fold it one more time and tear off the top right corner. And then before anyone opens their paper, you ask them who feels like their paper looks just like yours, because they all feel they did, right? They all followed, they all listened to directions. They're most likely going to raise their hands. And then once you open your paper, you open yours so they can see it, even if you didn't just do it right then, but open your paper and have them open theirs and have them look around, right? So they're looking at theirs, they're looking at yours. Does it look the same? Does it not? Have them discuss, why doesn't it look the same? Everyone was giving the same stuff, so why is it different? And it's going to be because, like I said earlier, we all have different backgrounds, experiences, and outlooks, right? So their folding might have been the hot dog way and somebody else did the hamburger way. And then when you fold it again, they might have folded on the previous fold or on the open end, right? Like this could go a ton of different ways. We all know we've made snowflakes with paper as kids, right? They never turn out the same. But so you're talking about the differences and how we look at things in a different way and the different outcomes from this activity. Even though you made sure everybody had the same stuff, the outcomes were unintended. It was an unintended consequence. You didn't mean for them to look different, but they did look different. So it's introducing unintended consequence to students and getting them to understand that even though they didn't mean for it to happen, it still could happen. And so it's something we need to be more considerate about. We need to think through, right? So the activity resource I gave you in the Google Doc is a link to this video, and it's the activity was inspired from one that Mr. Love did in this video through his Infinity, if I can talk, Consulting and Training Solutions. It's a fun video to watch, and you'll see all these adults in this room that do the activity and none of them look the same. So it brings on a lot of discussions, and I think it's really good. From here, the students are introduced to diversity. Prior to this, they're talking about what bias is. There's a video on bias. So they're getting a lot of really hard-hitting topics in one lesson, but trying to incorporate it and add it in different ways that make it meaningful to them. So that's what this activity is about. right, so before we start on this next slide, if there are any questions, please feel free to start throwing them in the chat. We covered one activity for each of the 5 big ideas, just a little activity to get you started on each one. Again, the Google Doc has all of the links for everything we talked about. The next 2 slides, we're going to give you some ideas and some things that you can look for moving forward. And then we're going to do Q&A with any questions we've got coming in. And then we're going to talk about the next webinar. So just so you know where we're going from here. So some ideas for how to get started with AI. Start small, which was the goal of this, was to give you one small activity to get you started in each 5 big idea. But add in an AI activity, either with concepts you already cover or something similar, right? Like if you're K5, you talk about the 5 senses. So you can start talking about, well, how do computers sense things? Patterns, right? Big in K2. If you're doing coding, throw in some of those uCode activities with the chatbot to talk about it. Rusty, anything you want to add to this bullet?
Yeah, and I think that's the right approach, because some of these concepts can be very heavy and daunting. So you don't need to start, with, looking at a piece of, code. You can start very small with, objects, that students can physically see, they can physically touch, and still make those big connections. Because I think the to scare kids right at the start. We want students to have this flow understanding and develop these core skills of which they'll be able to apply specifically to coding and computers later on. But at the start, it's better to approach these topics in a very personal, connected way.
Well, right. And I think societal impact is definitely the one that always makes me think of that. Like, you can't start talking about AI's impact on society and bias and unintended consequences if they don't understand what those concepts are. So let's get a good understanding of the base topics first, and then let's throw in the AI portion. And so that's kind of the second bullet point, right? Start with the basics. What do students need to understand about the concept before applying it? And that's really what we did when we broke down our curriculum, is okay, they need to know about sensors, but what are the basics of sensors? So then you've got the senses, and how is information taken in and how is it given out? Like, there are lots of things where you can break it down further and get those K2 kids or those 3-5 kids, depending on where your kids are at, trying to get them to understand the base concepts before moving on.
Great.
All right. And I think we talked about this a little bit already, is use what you know or use what they know already. So it's comfortable with them, for you, right? Students are already great at being consumers. And like Rusty said, many of us use AI in our daily lives. Do you use Netflix? Do you use Spotify? Do you talk to Alexa, right? Like, we use a lot of this without even thinking about it. And so getting the kids to stop and go, oh, that's what that is, like, that's going to help them make those connections.
Exactly. I think this is just where it also, spills over exactly to this next bullet point, is that we are such users of AI in our daily lives. The majority of us are interacting with AI multiple times a day, and having students be able to identify, how they're utilizing AI and the limitations of that method that they're utilizing AI, and just making it very personal will just make the learning a lot more impactful. And it's also really fun. These students, we're all interacting in these really cool ways with technology that, people weren't doing 10 years ago. And so just pointing out what's happening, it's just a gateway to learning these overarching concepts.
Exactly. And really the main thing is, if you're having fun with it and you enjoy talking about it, or if it's a fun activity, it's better than doing nothing, right? The goal for all the students moving in through the 4th Industrial Revolution and being consumers and users of AI is that they know what it is. They're exposed to it. They have some general idea of what's going on. Now, do they need to know every topic of machine learning? Not necessarily at the start, but do they need to know what machine learning is and how a computer learns? Absolutely. So get them started just by exposing them to different things with that. We're gonna give a shameless plug real quick, and we've got one slide on. But you know that we've done all the work. So we've got an AI Foundations curriculum. Like Rusty said earlier, it's K-12. We've got it broken up by grade band, K2, 3, 5, 6, 8, 9, 12. We've got 2 units per grade, 5 lessons per unit, so 10 lessons for each grade band. But like I said, they're very flexible. If you want to take them down, take them up, you certainly can. It's just trying to expose students to those basic concepts in different ways, making it hands-on. It's all free resources. You don't use anything you have to purchase. So that's fantastic in my book. But in case you want to learn more about our curriculum and you don't want to hear more about it, we're not going to talk anymore after this slide. There are 2 links and they're on that Google Doc. So you can go to our website, ubtecheducation.com. There's a tab up there for AI Foundations. You can learn about it. Or what we would encourage you to do is go to this login page, so ubtecheducation.com/login, and create an account. You can do it for free. You can see the login registers highlighted in the top right corner. You register for free. You can learn more about our curriculum back there. You get you can download samples of all of our curriculum. You can kind of see what we've got to offer for the classroom. So I think that's always fantastic, and it's free, and why not?
Exactly. Why not?
Yeah. Exactly. Douglas has asked, how much is the curriculum? Douglas, if you go to our website, you go to any of those, you could go to our UBTECH kits, you can go to AR Foundations. All the pricing is on our website because you can purchase directly from our website if you want to, through Shopify. So you can go right on there, ubtecheducation.com, and find that out. All right, Rusty. We've got questions. We have Mark, who gave us one of our questions ahead of time too. I have those pulled up, Mark. So your question is coming. His question is, does UBTECH have any experience with general AI used to serve as a teacher in the position of a human teacher? So AI taking over for a human teacher, do we have any experience with that?
And yeah, to add on, I mean, yeah, maybe Mark, you want to expand a bit on what you're looking for here.
If you want me to jump in.
Yeah, go for it.
Okay, so while we do have some humanoid robots, right? We've got Cruiser, kind of sort of has some arms and a face. We have Walker, who looks much more in a human shape. Our robots are really meant to help in the sense that, well, Walker is a different story. Let's talk about Cruiser. Cruiser with the big screen is meant to be like a hospitality type robot. So like I need directions to this store in the mall, or I don't know where baggage claim is in the airport, right? And you touch the screen and Cruiser would help you. We are not at that point where we are making walkers that can go into the classroom and teach at class. And I think as a company, or at least Rusty and I, we'll say Rusty and I, we don't believe that that's a great idea anyway, right? You need that connection. You need a teacher. We can't pass it off to the bots, right? We're not at that point in our technology yet. Are there resources you can use? Like there are adaptive, right? Adaptive websites that students can use that, base the questions and what they're presenting based off how the students are answering, right? So if they're answering a lot of questions wrong, it helps them reinforce those concepts that they're missing. But other than that, I mean, I personally don't want to see AI strictly in the classroom with no humans.
Yeah.
Yeah. Okay, so a couple other questions we had that came in ahead of time. Again, you can type in any questions as you want. Let's see. So we've got, where do I start with middle schoolers? So Rusty, if you were a middle school teacher, where do you think you should start? What would be a good place?
So this is where I think the 5 big ideas is such a perfect progressional approach to teaching these large concepts. So I would, and kind of, I guess an easy answer to the question is start with the big idea 1, start really understanding and analyzing perception and how computers are able to perceive the world. And kind of growing from there through at least the first 3 big ideas of AI education. So in terms of answering that question, where do you start with middle schoolers? I mean, start at the beginning, and I think this is where AI for K-12 did such a phenomenal job in creating these 5 big ideas. Because it's really laying out a really great pathway to dive into these larger concepts in a very digestible way.
Yeah, and just to build on that, it's so hard for us to know where your students are, right? Do your students already know about diversity and bias and block programming, you know, like, do they have the basics down? If that's the case, like, I would suggest starting a little higher. Like, if you were going to go with our curriculum, I would put you in 9-12 then, if they have that base knowledge. Your kids might not know anything about programming and AI and machine learning, then start way at the end and adapt the activities, right? But start with the 5 big ideas is definitely my recommendation as well. Start with the 5 big ideas. What can you teach? What basic concepts can you cover with each of those 5 big ideas that could get them prepared for more exposure later on in life? For sure. We have another question here. Do the lessons, activities in your curriculum require hardware or kits? So Rusty actually just put that in the chat. Nice job, Rusty.
Yeah. But they do not. So our AI Foundations curriculum is a standalone curriculum that does not require any extra hardware or software. So we do suggest utilizing or having access to Wi-Fi because some of the activities are online. But other than that, no, there's no additional hardware that's needed.
Yep. Another question we have is, how do I explain the purpose of models without getting bogged down in the math models for students? So this kind of goes along with all the stuff we've been saying, right? Even though you know, like, models in a computer world are numbers and binary and programs, and you don't have to present that right away to students, right? You could start where we did, like with a map. You're just showing them it's a visual representation of knowledge, and how is it helpful? How can you use it to reason? Just there's all sorts of different ideas in our curriculum for how to use models, and we don't ever get to the math portion. So,
yeah, and I think that the example that Kristina touched on for the K2 unit with the tree example, I think that's a great place to start, making it very personal. So if you're touching on, you know, say big data, it might be, you might think that you need to start, you know, in an algorithm, but really trying to pull it back and think about what that data is and focus on, you know, that first. So as opposed to going, you know, the binary approach, you know, and showing how this data is, you know, just pieces of just ones and zeros, basically, focus on what the data is, you know, focus on what the model is first. And that makes it very, you know, human. And I think that's how you want to introduce these heavy concepts and not, you know, having it feel bogged down with too much, you know, numbers behind it, basically.
Absolutely. We're going to go with one more question, and then we're going to talk about next month's webinar. So the last question, I guess, is going to be another shameless plug for ourselves, but what platform do you recommend and what coding language do you recommend? Python, Jupyter, GitHub. What is your recommendation, Rusty?
Well, you know, I do think that uCode is a phenomenal tool to be utilized. And yeah, I know that is a plug for us, but it's also very honest. Because Kristina and I we've utilized all classroom coding platforms out there. It'd be hard for you to point me one that I haven't seen. And I can say honestly that uCode is a premier coding platform. We have the ability to plug in actual AI integrated blocks into our program. You can utilize it for free. You just log on, go to the website and start playing with it. But it really does enable students to, you know, start at a very easy path and then, you know, really amp it up into, you know, do really complex things in a very easy manner.
And we should mention, so if you don't know much about uCode and you want to know more, we did a webinar on it in August. So you can go to our past webinars on our website and find that. But do know, like, we do have text-based coding mixed in with it. You can connect with Arduino, with our robots. Like, we build upon it. So if your students already know block-based coding and they're to the next level, right, you can still move on to syntax-based and all sorts of extra things. We've got lots of extensions and things that you can add in.
Yeah.
Okay, there are no new questions in the chat, although you're still welcome to ask them. We're going to tell you again, next month, we are doing Preparing for a Future with AI. So we're just expanding really on this one. We're going to do how will this help? How will this knowledge help kids? How will it make them better consumers of AI? And then we'll try to get some real life applications, maybe some more activities. You guys let us know. We would love to know, what would you like to see on next month's webinar in regards to AI? Do you want more activities? Do you want more real life applications? Feel free, tell us what you think, because here we go. Remember that this will be recorded, so you're going to get a recording of this webinar. You can reach out to us on any of those listed above, but also know that in the email you're going to get with the recording, there's a survey link. And so in that survey link, we ask you what you thought, but also what topics you have in mind, what you would like to see in future webinars. So please make sure, let us know, especially if there's something we didn't cover this month that you're like, I really wanted to know this for AI. Let us know so we can cover that next month. Okay. Anything else, Rusty?
No, I think you summed it up perfectly. Yeah.
You guys, it was so awesome to see all of you here. We appreciate you joining us every month. Oh, David Lockett, hello, how are you? I just noticed your name, sorry. Thanks guys for joining us. We hope to see you next month, November 10th, Wednesday. It's our last one for this year. We're not doing one in December because December is crazy for everyone. But then we hope to join you, or to start back up again next year, I guess I should say. So be on the lookout for that if we move forward with that. But anyways, have a great rest of your day, and we will see you next time.
Yeah, thanks everyone.
Thanks you guys. We're getting some great comments in there.
Great.